Hello and welcome to lecture number 14 in the course Advanced Robotics Applications. So in the last experiment, the last lecture rather, it was an experiment lecture in which we looked at the basic working of the microcontroller and how to connect various pins and look at how you can generate different voltages like 5 volts, 3.3 volts, how you can glow an LED, and how you can also generate PWM based voltages output. So today we move forward and in which we look at how do you connect various kind of sensors to the Arduino microcontroller. Now I'm trying to make the connection. I hope you can get the connection that basically what we are saying is that when you're controlling a robot has an actuator at the link. There is an encoder or a position sensor as which gives the position feedback. So we need to understand how to connect sensors and actuators to a microcontroller. Okay, so today we'll look at how to connect sensors like potentiometers, button cells, then encoders, and then we'll move on to actuators, and then we'll move on to robot control slowly. Interfacing using various digital and analog sensors with the Arduino Uno microcontroller. Okay, and our basic objective of this exercise is study the working principle of various analog and digital kind of sensors which we are going to use in future in the control of a robot. So a robot, as you would know by now, we are getting the position feedback of the joint angle using encoders. Okay, so how does an encoder work? How do you interface that with a microcontroller? Now, for obstacle avoidance and other applications, you may need other sensors also. So we'll look at we'll look at quite a few sensors that we're going to subsequently use in the next experiments. So for example, sensors like the button cell, these are basically on-off sensors. So on and off kind of sensors. Then we have Hall effect sensors, which are proximity sensors. Then we have infrared sensors, again proximity sensors, inductive sensors, potentiometers, which can be used for measuring the angle. Then we can have incremental encoders, and you can also have joysticks. Okay, so these are some of the sensors that we're going to study in class today. So these are some of the experiments that we're going to do. Now, as usual, this is the manual that we're going to follow. So the first task, that is serial number 1, is you have to upload the program which is already given onto the microcontroller GUI for the Arduino IDE. And the first one is for the button cell. So what we are supposed to do is what is written here. So press the button cell and observe the state of the built-in LED. Okay, so when you press the button cell, does the LED come on or does it come off? So also try to correlate this with the program. Okay, so I'll also explain the program just before the experiment, that what is the program actually doing. Okay, so you should be able to correlate between when you press the button cell, what is its effect on the LED. Then Hall effect sensor, that's number 2. Okay, so we upload the program for task number 2. These are different programs. Observe the program carefully, and then we bring different kind of objects. We bring a magnet near the Hall effect sensor, okay, and see what is the output on our serial monitor. Okay, that's number 2. Number 3 is infrared sensor. So we make the connection using an infrared sensor, and when you bring an object near an infrared sensor, then what is the effect it has on the LED. Okay. Third is inductive proximity sensors. These are proximity sensors which can be used for measuring speed or rotation of a gear. Okay. So here again, it is a proximity sensor, so it basically detects metal. Okay, so this is a magnetic sensor. So basically, if there is a metal, it detects that metal, and it can be used for counting. It can be used for if something is rotating, as you'll see, you can exactly count how many rotations have taken place. Then potentiometer, which we had discussed several classes ago for sensors and actuators. Now, potentiometers can be used for measuring angle. Okay, so the experiment here is to connect the potentiometer as shown in the figure, and then rotate the potentiometer and see how the angle changes. Then we have after that we have an incremental encoder. So the encoder, we have explained, this is an incremental encoder. So basically connect the encoder as shown, and when you rotate, what is seen? Okay, then for example, if you're rotating in one direction, what do you see on the oscilloscope? If you're rotating in the other direction, what is it that you see on the output? Okay, the output can be an oscilloscope. The output can be your serial monitor also. Serial monitor, I mean the serial output which is coming on your laptop or computer, wherever you have connected it. Okay, and then joystick. So this is a joystick based control. well, if you move the joystick in different directions, the joystick is connected to a red and blue LED. So depending on which side you have moved it, the LED, corresponding LED is going to glow. Okay, so these are the 7 experiments that we are going to do today. So the first one is the button cell. So this is the button cell which is shown here. So it's like a button. The button is there. If you just press it, so this is an on-off kind of sensor. So make the connection as shown here. We are going to connect one end of the button cell to 5 volt, which is giving the voltage to the button cell. The other end is going to ground, and we're taking the 2 outputs from here and here onto number 3. Okay. So now this basically what we are trying to do here is when you press the button cell, the circuit becomes on. So probably your LED is going to glow. Okay, or LED will go off depending on what you've written in the program. So this is an on-off sensor or on-off switch. Suppose at a particular joint when the robot is moving, suppose I have a robot or 2-link manipulator like this. Okay, when it is moving and this link is going to hit, so there will be some range of motion from here to here, right? So when this link goes here and hits, there would be a button cell here or an on-off cell. So when this link goes and hits that, it will immediately switch off the power supply. It knows that it has reached the end of the work volume. Okay, so that is the use of the button cell. Next is Hall effect sensor. This is used for sensing proximity. So this is your Hall effect sensor, which is very, very small. So we make the connection as shown in this figure, and then what we are supposed to do is we bring a small magnet near the Hall effect sensor. Okay, so when you bring the magnet in front of the Hall effect sensor, the LED will probably glow. Okay, so this is basically to show that an obstacle has come in front. Now if you reverse the direction of the magnet, does it still glow? So you can check it out. So we'll check it out and see what happens if you change the direction of the magnet. Now this is a Hall effect sensor, which is a non-contact sensor, basically checking if there's a magnetic material in front. The third is infrared. So this is an infrared type sensor, which is pretty commonly used. So this is the emitter, so the one there, and this is the receiver. So this is an emitter receiver pair. Let me change the color. It's not very clear there. So let me change the color, and okay, so this is an infrared sensor here, and basically what it is showing us, this is an emitter and that is a receiver. So it is an emitter receiver pair. One of it emits the IR light, it goes and hits an object, and then it comes back to the receiver. So on top of this, if I place an object like that, okay, it is going to sense that the object is there, and probably the LED is going to glow, indicating that an object is there. Okay, so this is an infrared sensor. Then inductive proximity sensor. This is what we are talking about in terms of counting rotations. So this is a sensor which you might have seen. It is quite commonly used in industries, and this one is a wheel having 3 arms like this. Okay, and there is a metallic screw in there. That's my metallic screw that you can see there. So when this rotates, what happens, as soon as the metal comes in front of this inductive sensor, it senses. Okay, and when you rotate it, depending on how fast it is rotating, it can tell you how fast the system is rotating and how many times this has rotated, simply by counting how many of these metal parts have come in between. Okay, the connection is as shown here. Then potentiometer. This is the connection to the potentiometer. So this is a potentiometer which is shown here. So we can connect the link of the robot here. Okay, just for example, I'm saying that I connect the link of the motor here of the robot, and when it rotates, what happens is the voltage across the 2 terminals are going to change. Okay, so based on that, we can basically find out what is the position of the link now. So this is a potentiometer. This is an analog device, and basically we can find out the angle of a link by how much it has rotated. After this, we have the incremental encoder. Okay, so this is the encoder here, and the connection for the encoder is also shown here. Okay, now in the case of the encoder, I can fix the link here. Again, the same like a potentiometer. So when the link rotates, what happens? It basically counts the incremental encoder. You'll remember how it works. So it's going to count, and it's going to correspondingly tell us how much angle it has moved. Okay, and then we have the joystick, RGB joystick. Okay, now this is the joystick basically, this one here. So we are connecting this to the red LED and this one to the blue LED. So in the joystick, I'm sure you're familiar with joysticks. You can play for playing games and for other applications. So if I move it in this direction, the blue LED is going to glow. This is my, so here we have a blue LED and a green and a red LED, that one on top there. So when I move the joystick in that direction, what will happen is the blue LED will glow. If I move it in this direction, then red LED will glow. And if I move it jointly in both the directions, then both will glow. How does it sense? There is basically a potentiometer in there. So there are potentiometers which are controlling the voltage that is going out to the y-axis or the blue LED, and the voltage that is going to the red LED. So depending on how much direction you have moved, it is going to supply that much voltage to the red or the blue LEDs. Okay, so this is basically our second experiment to get us familiar with how do you actually use a sensory feedback in a closed loop control system. So we are going to use an incremental encoders in robot control. Okay, so this is how an incremental encoder actually works. So the first is the button cell, which is here, which is shown here. So the button cell is basically an on-off switch, and when you press the button switch, what will happen is it will the built-in LED is going to glow. Okay, so let us first upload the program of the button cell. So this is the button switch program. So it is connected to the Arduino Uno in COM3, and what you can observe is that the line number 11 says LED output. So LED is LED number 13, the pin number 13, which is line number 5, and the button switch pin is connected to channel number 3. Okay, so the button switch's output is connected to channel number 3, and you can see in line number 11 and line number 12. So the pin mode is LED pin 13 is an output pin, and the pin mode for button pin, which is your pin number 3, is an input pull up. Okay, now what we are seeing here is line number 17 is a digital read from the button pin. So if the value is high, then it will make the digital write LED to low, else it will make it high. Okay, so that is you should correlate what the program is written in terms of the working of the sensor. Okay, so here it says that if the digital read button pin value is equal to high, then it will digital write on the LED, that is channel number 13, and make it low, else it will make it high. Okay, so let's run the program. So we will compile the program and then run it. Okay, this is a button switch. Now let's look at the button switch, which is very small here. You can see that. So the black switch in the center, that is the button switch in there. So if you depress it, what will happen is, if you press it, what will happen is that the LED is going to glow. Okay, so if you press it in there, you can see that the LED is glowing. So the LED, you can see that LED there is glowing once you press the button switch. Okay, this is like an on-off switch, and it is very useful in the case of a robot or in the case of a CNC machine, because when the robot link has reached the end of the its traverse or the end of the work volume, then there would be a button switch or a limit switch where it will hit the limit switch, and the robot controller understands that it has reached the end of the work volume. Now in the case of a CNC machine also, these are used at the end of the work table. So when the work table is moving, what would happen is, when it has reached the end of the work table motion, it is going to hit one of the limit switches, and automatically the power to the motion will get cut. Okay, so this is, again, you can see that there are 3 wires which is going. So there's a green, maroon and black wire. So one of them is taking the signal, the other 2 are giving the power. Okay, and they are connected correspondingly to the corresponding so we had seen that in the program it is connected to the pin number 3. Okay, so that is how it was connected. Okay, the next one is a Hall effect sensor. So the Hall effect sensor, as we have explained in class, basically can detect a ferromagnetic material which is coming in front. So what happens is, if there's a ferromagnetic material which comes in front, the Hall effect sensor will detect the material, because the magnetic lines of force are going to be pulled out into that material, and that is how it senses that a ferromagnetic material has come in front. Okay, so we connect the Hall effect sensor. Let's download the program of the Hall effect sensor. So this is the program of the Hall effect sensor. Okay, and
So it is setting the pin mode, line number 12, to Hall pin as input pin. Okay, so this is the Hall effect sensor which is connected to the Hall number. So the pin line number 6 is telling you the Hall pin, Hall effect sensor, is connected to channel number 2. Okay, and the pin mode of the channel number 2 is an input pin. And then it says that the sensor value is digital read of the Hall pin. Okay, and line number 20 and 21, it says serial print sensor value read at digital pin input, which is under inverted commas. So it will display this, and whatever is the value, it is going to indicate the value on line number 21 and that pins. Okay, so let us run the program. So basically what will be the output, whether the sensor is detecting the object or no object. Okay, that is the output that is going to come. So let's download the program. Okay, so now we are downloading the program and it is running. Okay, so you can see that it is saying magnet not detected. So the moment the magnet comes in front, it says detected, as you can see in the display. Okay.
So this is the Hall effect sensor. You can see that in front it's a very small sensor. So that is the sensor which is extremely small. So that is the Hall effect sensor. Okay, it's extremely small. So again, there are 3 wires there. One is taking the input to the sensor, the other 2 are power. And these are basically connected on the microcontroller in the pin numbers as indicated. Okay, so there is a connection to the power side, and there is the Hall effect sensor is connected to pin number 2, that is shown there. Okay, now this is the sensor. Now if there is a magnet which comes in front of it, so this is the black color small magnet. Now the moment the magnet comes in front of the, and let's look at it like this. So if the magnet comes in front, you can see that. Okay, so this is a magnet, and if the magnet comes in front of the Hall effect sensor, immediately it detects that the magnet has come in front. You can also see that the LED is glowing there. Okay, so there is that LED which is glowing. Okay, just as the magnet comes in front of the sensor, the LED is glowing. Okay. Okay, so that is basically detecting that so the Hall effect sensor is detecting the magnet that is coming in front of it. Okay. Now, when the magnet is coming in front, you can also see that it is showing on the display. Okay. Yeah, so now it is showing 0. That means the magnet has come. Magnet detected. It is showing. You can read that. It is saying magnet detected. Okay. And the LED is glowing on that side. Okay, so here the LED is glowing. You can see that the magnet has been detected. Okay. So this is fundamentally how a Hall effect sensor works. Again, Hall effect sensor is very useful for detecting presence.
The third is infrared transceiver pair. Now this is a proximity sensor which consists of a IR transmitter and a receiver. So the IR transmitter transmits infrared rays, and this ray goes and hits the object and then comes back to the receiver. Now when there is an object in front, basically the IR comes back, and that is how the sensor detects that there is an object in front. Okay, this is a proximity sensor which is basically checking if there is an object in front. Okay, let us download the program. So infrared transmitter receiver. This is the program. Okay, so again you can see that we set up the pin is pin number 3 and the LED is connected to pin number 13. Okay, and line number 15 says pin mode, the LED pin is an output pin. Okay, and pin mode, the button pin is an input pin. So this button pin basically means the sensor, which is the IR sensor. Okay, so let us compile the program and then upload. Okay, so what you can see is that the program has been uploaded, and if an object comes in front, then the LED glows.
Let us look at the emitter receiver. So this is the connection diagram of the microcontroller. So we can see the connection to the microcontroller board which has been made. Okay. Then this is the emitter receiver which is there. So if you look very carefully, there are two of them there. So let me look at it very carefully, or very, yeah, so there are two of them there. One is an emitter and the other is a receiver. So emitter and receiver. So one is emitting an IR, the other is receiving an IR. Okay. So if you bring an object in front of it, what will happen is it will detect the object and the LED is going to glow. Okay. So let us bring an object in front. Yeah. So there is an LED fixed onto the sensor itself. The red one you can see there. So if you bring anything in front, for example, he's bringing his finger in front and it is immediately glowing. Okay. So this is again a very useful sensor in terms of detecting if an object is coming in front. Okay, this is a non-contact kind of sensor, so it can detect objects.
The next experiment for us is the inductive proximity sensor. Now the inductive proximity sensor, as the name indicates, is an inductive sensor. So it induces a magnetic field in the ferromagnetic material which is coming in front of it. Okay, and that is why it is called an inductive sensor. And how it works is that if there is a magnetic material coming in front, the magnetic lines of force are pulled out to that material, and that is what is sensed by the sensor. And once the sensor senses something has come in front, it gives a reading that something has come in front. This can be used also as a counter. So for example, if there is a wheel or a gear which is rotating and you want to count how many of the teeth has passed through, okay, or if you're trying to measure the number of rotations of the crankshaft, then what we can do is we can put a projection on the crankshaft, and every time the projection comes in front of the sensor, it will give a reading that it has the object has come in front of the sensor. So this is the program for the inductive sensor, and you can see that the variables here are given. It is counting the number of pulses here. Okay, so every time, the way the program is written is that in the circular wheel that we'll show in the video just shortly, so there are three projections on the wheel, okay, and three of the screws have been put on the wheel which is rotating. So we want to count how many times the object has come in front of the proximity sensor, and that is your pulse count. Okay, so it keeps counting how many times a ferromagnetic material has come in front of the object. And then line number 19, you can see it has a digital print which says pulse count, and then it displays the actual count. Okay, that means if it is 1, 2, 3, 4, as it is moving, it can count and it will keep displaying how many times the object has come in front of the object of the sensor. Now, as this can be used in various applications, for example, the speed of a shaft, you can count the number of rotations of a gear. Okay, so let us run the program and look at. So it is saying pulse count is 0, 1, 2, 3, 4. You can see at the bottom that the pulse count is increasing as we are rotating the shaft, as we are just showing it in the video. This will just show in the video what it is doing. It is just counting how many times a ferromagnetic object has come in front.
Now this is the setup, and this is basically the sensor, the proximity sensor. Okay. So you can see that this is the proximity sensor and this is the front part of it. The front part of the sensor is here basically. So that is the part of the sensor. Okay, this part here. And what we are trying to detect is that we have made a sample something like this, a rotating wheel, which you can see the wheel, it can rotate. And in front of the wheel, there are the screws which are fitted. So what it detects is when the screw comes in front of the sensor, it detects a change in the magnetic field. Okay, and then it gives a count of 1. So depending on how many times the screws have come in front of the sensor, it is going to count. So when the shaft is rotating, if 3 screws have passed, that means it has gone through 1 full rotation. Okay, that is how we can count rotation or speed of rotation. Okay, so this will basically give you speed, and if you know the time, then you know the velocity also. This is the connection diagram again of the microcontroller. it is connected to pin number 2, you can see, and the other side we are giving it the power. Okay. Okay, so let us rotate. We can rotate this very slowly, and every time when we are rotating, what is happening is that it is counting. So you can see that here we are rotating very, very slowly on the serial monitor. It is showing pulse count 1, 2, 3, 4. We are rotating very slowly. Maybe we can rotate a little bit faster. So this is how it can count how many times an object has gone in front of it. So if you know the velocity, if you know the time between these counts, then you also know the velocity of this object.
The next sensor that we are going to study is the potentiometer. Now the potentiometer, as was explained earlier, basically checks for the change in resistance. So what we do is when we are rotating the potentiometer, there is a change in resistance compared to the reference resistance. So it's a small r by a capital R. So when we are moving the potentiometer, what happens? The potentiometer knob is connected to the contact point inside the potentiometer. Okay, and based on that, as you are moving it, there is a change in the two resistances, and that is basically what it is showing. So let us look at okay, so this is basically the program for the potentiometer. So what it is doing, it is reading the analog read of the potentiometer pin. Now the potentiometer pin is connected to A0. Okay, that's an analog input pin for the potentiometer as shown in line number 5. So as we are rotating the potentiometer, what is happening? The resistance is changing. The ratio of the resistance is changing basically. So what is happening is the voltage that it is receiving is changing. Okay, and this is getting mapped onto a particular scale. For example, the sensor value is being mapped from 0 to 1023. Okay. And what it is displaying here, line number 23, is serial print. It is saying mapped value, and what is the mapped value. Okay, and you can see that. So let us upload the program. So compile it and upload the program. Now what you see here on the display, okay, yeah, so when we are rotating the potentiometer, what you're seeing, the sensor value and the map value. Okay, so this is the sensor value and the map value. So 0 to 1023 is being mapped from 0 to 255. That is what it is showing. So we can calibrate this, for example, 0 to 255 degrees. If we say, then it can correspond from 0 corresponds to 0 and 1023 corresponds to 255 degrees. So by looking at the sensor value, you know exactly what angle you are fixed at. Okay.
Let us look at the connection. So this is the connection of the potentiometer. So this is the potentiometer. Okay. So what we're going to do is, if you're going to attach a link, we can attach the link here like this. Okay. So we can attach this to the link. So when the link rotates, this will rotate. Okay. So I hope you understand. So we can connect the link here like this. Okay. This is the link now. So when the link rotates, this potentiometer is going to rotate. And again, it has 3 pins. One of the pin is connected to the A0. Okay. And the other 2 are power. So what you can see here is when we are rotating it, we can rotate. So we can rotate it. So you can connect it to a link and then rotate it. Okay. So when you're rotating, what you can see is that the link angle is changing, and that angle is being reflected. Here. Okay. In the serial monitor. So this is how potentiometer works, and this can be used for measuring the angle of a link. Although potentiometers are pretty noisy, and because there is contact, so there is change in contact resistance, so there is a lot of noise that this reading gets affected by noise.
The next experiment is the incremental encoder. Now the incremental encoder is probably one of the most important sensors that are used in robotics, because we need to measure the position of the motor shaft. We need to measure the velocity and the acceleration of the motor shaft also. Okay, so basically at the rear of the motor shaft, a digital encoder is installed always, and when it rotates, basically it gives a 1010 kind of signal, and that is picked up by the controller to understand what is the position, velocity, and acceleration of the motor shaft. Okay, so let us look at this incremental encoder experiment. So this is the program. So it has encoder pin 1, encoder pin 2. Okay, so it has 2 channels, and there is a LSB and MSB for this. So encoder pin 1 is connected to channel 2, and encoder pin 2 is connected to channel 3. Okay, now let's look at this. So when it is moving, what is happening is that the signal is becoming low and high, and that is your input pull up and input pull up given in line number 21 and 22. Okay, so for encoders pin 1 and pin 2. So let us compile the program and upload the program. So now it is connected to the encoder.
Change the baud rate.
Second number 11520. Okay, so now you can see that the encoder has been connected, and as you're rotating, what is happening? The number is changing. That is basically giving you the number of counts. Okay, so as the encoder is changing, this is corresponding to the number of counts that have passed through as it is rotating. So we can compute the velocity if you know how much time it has elapsed between, and how many counts have elapsed in that particular time. Okay. So this shows the connection to the encoder. So the encoder looks very much like the potentiometer. So it is inside, and we have made the connection here, okay, of the encoder. And you can see that when we use this for measuring the link of a robotic arm, what we can do is we can connect the link here like this, and when it rotates, this encoder is going to rotate. Okay. So basically you can see here the encoder is rotating, and the number of counts that are going through is being shown on the serial monitor. Okay. So this is a digital device, and this is how the encoder works. Okay, this is probably the most important sensor in robotics and automation. The next experiment is the joystick. Now the joystick is an interesting experiment. You must have used joysticks in various applications. Now the joystick here basically consists of 2 axes, the X and the Y, and in each of the axes a potentiometer is fixed. Okay, so when you're moving along, for example, the X axis, what happens? It increases or decreases the resistance along that axis, in that direction rather. And there are 2 axes, X and Y, and both of the outputs from this X and Y axis are connected to 2 LEDs, okay, red and a blue LED. So if you move more in the X direction, then one of them is going to glow more, and if you move in the other direction, the other one will glow more. Now if you go in between them, what will happen is they'll glow equally. So essentially we are controlling the voltage that is going to the LED by changing the position of the potentiometer, and the potentiometer is connected directly into the joystick handle. So when you're moving the handle in a particular direction, the voltage in that direction changes, which means the voltage that is being supplied. But if you move in a particular direction, then what happens? The resistance in that direction changes, and because of which the voltage changes to the LED. So let us look at the So this is the program for the LED. So it has potentiometer values in the X direction, which is corresponding to brightness in the X direction, and the potentiometer value in the Y direction, which corresponds to brightness in that particular direction. Okay, so you can see that is given here. Okay. Okay, let us compile the program and. Okay, this is the joystick, you can see, and that is the LED. There are 2 LEDs there, blue and red color, and this is the joystick, which is connected to the microcontroller board there. So by moving the joystick in different directions, you can change the amount of light that is going into the encoder. You can change the amount of voltage that is going into the LED. Okay, so if you're moving the joystick in a particular direction, so there are 2 axes. Let's look at the joystick carefully. So let's look at the joystick very carefully here.
So if you're looking at the joystick, it is marked in terms of X and Y. So in one direction it is X and the other direction it is Y. Okay, so I can say that this is my X direction in this direction, and that's my Y direction in that direction. So when I'm moving the joystick in a particular direction, I can move it this side, or I can move it this side or this side. Okay, so when I move the joystick in these two respective directions, the voltage going into the LED is going to change. Okay, and that is what we are seeing. Okay. So when you're moving the joystick in a particular direction, let's move it from this side. So when I move it this side, okay, this is becoming blue. When I move it this side, that is becoming red. Okay, so these are connected to two potentiometers which are controlling the amount of voltage that is going into the LED. Okay, so this is how a joystick works. Okay, and if you push it in between the X and the Y, then the voltage will go equally in both directions. Okay.
Okay, so today we have looked at the sensor interfacing with the microcontroller, and in the next class we'll move on to control of motors. We'll move on to control of stepper motor, and then we'll look at servo motors.